all its history humans were raising their heads up and admired the starry heavens. But how this magnificent spectacle would look like if our eyes could see in other forms of light, as infrared, gamma rays, and especially in the hazardous for life X-rays. Very different for sure. Light consists of electromagnetic radiation at many different frequencies. Most of them are invisible by the human eye and the optical telescopes. There are radio waves, microwaves, infrared radiation, optical light, ultraviolet radiation, X-rays, and gamma rays. All these forms of light comprise the electromagnetic spectrum. Celestial bodies usually radiate at many wavelengths simultaneously. They emit more in some wavelengths than others depending on their temperatures. The hottest and most violent processes emit at small wavelengths, that is X-rays and gamma rays. While the cold and calm processes emit at larger wavelengths, such as in the infrared and radio. The vast majority of the electromagnetic radiation cannot penetrate the Earth's atmosphere, so we are using orbital observatories. Most notably, the high-energy ultraviolet, X-rays and gamma rays cannot be observed from the Earth's surface. Up to now, many X-ray observatories were successfully put in orbit, revealing the hot and energetic side of the universe. The next step forward is the European Space Agency's Athena mission, which will be launched in 2028. It will revolutionize our knowledge of the high-energy universe, carrying the largest X-ray telescope ever constructed. Athena will be 100 times more sensitive than the best of existing X-ray telescopes. With all these observatories we observe the birth of new stars in regions where large molecular interstellar clouds exist. We also study the violent death of massive stars that take place during supernovae explosions. After the explosion, the cores of stars with high masses end up in what we call stellar black holes. From these stellar remnants nothing can escape. Matter, as it collapses onto black holes, creates an accretion disk around them. In this disk, the temperature and kinetic energy are so high that X-rays are generated. The death of medium-mass stars creates what we call neutron stars. These objects spin at very high velocities and their radiation can most easily be observed when the beam of emission is pointing toward Earth. This creates periodical changes in their luminosities, and this is why we call them pulsars. We also observe binary stars that are very close together and interact strongly with each other. There are special cases where one of the binary stars is very dense, like a neutron star or a stellar mass black hole. In these cases, mass is transferred to the neutron star or stellar black hole from the accompanying star. Then an accretion disk is formed which emits large amount of X-ray radiation. We observe the results of the merging of two common stars or the more violent merging of two neutron stars. These mergers always end up in the brightest explosions known that produce X-rays and gamma rays. The gamma ray bursts. Less often, but at larger scales and more impressive, are the mergers of two black holes. These are the most violent phenomena in the universe. We also observe the center of our galaxy, where a black hole interacts with the surrounding matter. Studying the motion of nearby stars has revealed that the mass of the black hole is 4 million times the mass of our Sun. We also study in detail galaxies that emit huge amounts of energy from their nuclei and are known as active galactic nuclei, radio galaxies, quasars and blazars. These galaxies have massive black holes in their center, with masses 1 million or even 1 billion times the mass of our Sun, and accrete huge amounts of matter. They also have jets that extend out into the intergalactic medium. We observe the interactions, collisions and mergers of whole galaxies, that play a crucial role in their evolution. Galaxies are organized in clusters and superclusters. These are the largest bound structures in the universe, filled with gas at millions of degrees, which shines brightly in X-rays and is invisible at all other wavelengths. They grow by feeding from gas distributed in the large-scale structure of the universe. Finally, we can observe the primordial universe, where the death of the first stars was much more violent and the interactions and mergers of the galaxies was taking place more often. Athena mission is expected to reveal the physics of the enrichment and heating of our galaxy's interstellar medium by supernova explosion. To determine how and when large-scale hot gas structures formed in the universe and track their evolution from the formation epoch to the present day, and transform our understanding of two major questions in astrophysics: how ordinary matter assembles into large structures, such as galaxies, and how black holes grow and shape the cosmos. The Athena X-ray Observatory will revolutionize our understanding of the most violent and energetic phenomena in the universe, and it will unveil the secrets of its evolution.